Okay, so today we're going to look at the areas of trapezoids, rhombuses, and kites. There's only two different formulas for this, so it'll be perfect. First thing we're looking at is the height of a trapezoid, which is just the perpendicular distance between the bases. Okay. And the area of a trapezoid, our actual formula is going to be the area equals 1/2 times the height times the sum of the bases. So we're going to add our bases together, okay? So if we come down here, we have a nice map of Nevada. If you didn't know, Nevada is a trapezoid. So what we want to do is find the approximate area of Nevada. So our bases going to be this 205 miles and this 511 miles down here. So we are going to have the area equals 1/2 times our height. So our height is the distance between those two bases, which is that 309. So 309 times our bases added together. So we have 205 plus 511. So that gives us 1/2 times 309 times 205 plus 511, which is 716. And when we put that into our calculator, that is going to give us 110,622. And since it's area, it is going to be miles squared. Okay. If we go down here, it says that we have a trapezoid with the height of 7 and bases of 12 and 15. So we have the area equals 1/2 times our height, which is 7, times the sum of our bases, so 12 plus 15 gives us 1/2 times 7 times 27, and when we put that into our calculator, gives us 94.5 centimeters squared. Okay. So now we're going to find the area using our special right triangles. So if we have our right triangle right here, you know that this whole side is 7 and this shorter side is 5. So if we take 7 minus 5, that leaves us with 2 right here. And we want to find the height of this trapezoid. So if we have a 30, 60, 90 triangle, we know that our shorter side is S, and our longer leg is going to be S square roots of 3. So that means that our height is going to equal 2 square roots of 3. So our area is going to be 1/2 times our height, which is 2 square roots of 3, times our bases added together, so that we're going to forget about this 2. And we've got 7 plus 5. Okay, so that leaves us with 1/2 times 2 square roots of 3 times 12. And when we put that into our calculator, that gives us about 20.8 meters squared. Okay, so in this problem above, if we decrease the height so that the area or the measure of that angle P is 45. So if we have this like this again, so this would be 45 and this would be 45. Make a right triangle. We still have that this is 5 and this whole thing is 7. Okay, so that means that this is still going to be 2. So that means that our height would actually equal 2. So when we put that into our equation, we would have area equals 1/2 times our height, which is 2 in this instance, times 7 plus 5, which gives us 1/2 times 2 times 12, which would just give us 12 meters squared. So it just changes it a little bit. On to our next page. we are looking at the area of a rhombus or a kite. We have the same equation for both rhombuses and kites. So our equation is just going to be the area equals 1/2 times one diagonal times the other diagonal. Okay, so right here we have a kite. We know that this diagonal right here is just that 3 plus 3, so the diagonal 1 is going to equal 6. And our longer diagonal is going to be 2 plus 5, so we have a diagonal 2 equals 7. So if we put that into our equation, we are going to have A equals 1/2 times 6 times 7, which would give us 21 meters squared. Okay. Our next one, it says that we have a kite with diagonals of 12 and 9. So we would have area equals 1/2 times 12 times 9. And when we put that into our calculator, that's going to give us 54 inches squared. Okay. And our last page, we're finding the area of a rhombus. So what we know about rhombuses, they make up, their diagonals create right triangles. So we know that this little side right here is 2.5 and this side right here is going to be 6.5. So we need to find this side right here. So to do that, we have x squared. So if this side is x, we have x squared plus 2.5 squared equals 6.5 squared. So that gives us x squared plus 6.25 equals 42.25. So we're going to subtract that 6.25 from both sides. That leaves us with x squared equals 36, and that means that x equals 6. So our diagonal 1 is going to be 6 plus 6, which equals 12. And our diagonal 2 is going to equal 2.5 plus 2.5, which equals 5. So our area equals 1/2 times that 12 times that 5, which if we put that into our calculator gives us 30 feet squared. Last one right here, we have a rhombus with sides of 10 meters long. So a rhombus, remember, have the same lengths and their diagonals. So we have a rhombus with 10 centimeters, and it says that the longer diagonal is 16, which means that half of it is going to be 8. So we want to know this little part right here to be able to find the area. So we're going to do x squared plus 8 squared equals 10 squared using the Pythagorean theorem. That leaves us with x squared plus 64 equals 100. If we subtract 64 from 100, that gives us x squared equals 36. And just like last time, we have x equals 6. So that means that this is 6, which means that this is 6. So our diagonal 1 we know is 16. And our diagonal 2, we do 6 plus 6, which equals 12. So our area is going to equal 1/2 times 16 times 12, which should give us 96 centimeters squared.